next we have the representation of cell. Here we are representing the cell. The whole cell is represented in a single line. And by just observing that line, I can explain each and everything about the given cell. Even we can write the reactions, we can write the E naught cell of value, we can write the conclusion. That means everything can be written only just by its representation form. We had written the cell representation for Daniel cell also while talking about the Daniel cell. So now how to write the cell representation? There are the certain rules which we follow for writing the cell representation. The rules which we follow, the universally it is accepted, and so that the elaboration of the cell representation should be easy. So now let's see the cell representation. Suppose I just wanted to represent the Daniel cell. I just want to write the representation of this Daniel cell. So for writing a cell, you have to write only those things which are different in all the cells. So different thing is going to be like the electrode and the electrolyte. These are the two things which are different in all the different cells. So here, suppose if I want to write the Daniel cell is made up of the two half cell. One is a zinc and the second is a copper. So first, before writing the cell representation, let us first represent each half cells, that is each electrode. So rule says that a single electrode will have two different things, that is a electrode and electrolyte. So just write electrode and electrolyte. So first one, that is a zinc. So it is made up of zinc electrode, and the electrolyte is zinc sulfate. Or I can write zinc sulfate first and then zinc electrode. Here then mention the state. Zinc is in solid state, that is the electrode it is, and zinc sulfate it is in a aqueous state because the solution dissolved in water. Then rule says that instead of writing the full name of the zinc sulfate, that is the full name of the electrolyte, just mention that ion of a electrolyte which is taking part in the reaction. So from zinc sulfate, which produces two ions, zinc ion and sulfate ion, so I can say that from these two ions only zinc ion is taking part in a reaction. So here I can write, instead of writing full zinc sulfate, I will write zinc and then zinc ion. Or it is in aqueous state, or it can also be written like this: zinc ion and then zinc solid, and this is aqueous. Then rule says that if you know the concentration of the electrolyte, then better to write the concentration also. So here I know the concentration of the zinc sulfate, which is represented by zinc ion in representation. So if you know the concentration, then write concentration also. Zinc in a solid state, then zinc ion whose concentration is 1 molar, here I can say. Similarly, I can write zinc ion, means I can write zinc ion first and then 1 molar and then zinc. So this is about the first one, that is this. And then we have copper electrode. Then copper electrode CO, it is in solid state, and then copper ion whose concentration is again 1 molar. So this is the first half cell, this is the second half cell. Now the time to combine both the half cells. Now this vertical line, here the vertical line is drawn only for the separation of the phases. Here I can say this is solid and this is aqueous, that is a liquid state. That's why the vertical line has been drawn just to separate these phases. Again, solid and aqueous, phases separation. Okay, now I just want to write the whole cell combination. There is a whole combination. So for the whole thing is combined, that is both the cells are combined with the help of salt bridge. So here also we do the same thing, where like both the half cells are going to unite together by using a salt bridge. So salt bridge, here when I'm using a word, the salt bridge is represented by the double arrow, the double vertical line. This is the salt bridge. On the left hand side and the right hand side, we write something on the left hand side of the salt bridge, and the another cell, half cell, is written on the right hand side. So suppose on the left hand side, I can say, and this is right side of the salt bridge. As I said, this is salt bridge. Right side. On the left hand side, we consider that electrode which undergoes oxidation. And the electrode where oxidation takes place is called as an anode. And the anode, in case of we are talking about the galvanic cell, the anode is the one which carry negative charge. The right hand side, on the right hand side we consider that electrode, or that electrode is considered where the reduction takes place. The reduction takes place at cathode electrode, and cathode is a positive charge. Now just for remembering, I can simply say that all the things which comes alphabetically first, they are written on the left hand side, and the one comes alphabetically later is written on the right hand side. From left and right, L comes first. From oxidation and reduction, O comes first. Anode, cathode, A comes first, and negative, positive, N comes first. Or simpler than this, I can say the way of remembering, this is L, O, A, N, that is lone. So lone word, that means all the whatever the things are involved in this, they all are written on the left hand side. So LOAN, lone. Okay. Now left, so salt bridge. I will write on the left hand side of the salt bridge, I will write that electrode which comes for, which is where the oxidation takes place, that is the anode. Now from the Daniell cell, I can say that in a Daniell cell, the oxidation takes place on the zinc half electrode and the reduction takes place on copper half electrode. So I will write first this and this one later. The rule says that again, while writing a complete cell, the cell should start with the electrode and should end with the electrode. That means that two electrodes should be written on the extreme ends. Here we consider the electrode, while writing the cell, we consider the electrodes and the ions. Then it means the rule says that the cell representation should start with the electrode and ends with the electrode. So let us write on the left hand side anode, which will be written first from zinc and zinc ion. Then rule says that electrode should be written first. That means I will start with the zinc in solid state, single vertical line, zinc ion. I know the concentration, so I will write concentration. Once concentration is written, the person will think that okay, it is in aqueous state. Then once the anode is over, a salt bridge, that is a double vertical line. Then cathode. Cathode is a copper and copper 2 plus ion, which will be written first. It should end with the copper electrode. That's why it will first copper ion, whose concentration is again I know 1 molar, and then copper, that is solid. Okay, so this is a representation of the Daniell cell. If you will see the same representation I had written in the Daniell cell while talking about the Daniell cell. So this is the Daniell cell representation. Now by using this one line or one state, I can explain everything about the Daniell cell. Like I can say that in a Daniell cell there are the two half cells. This is the one and second one. The first half cell contains the zinc electrode which is placed in 1 molar zinc ion solution. Copper electrode placed in 1 molar copper ion solution. Then how to write the reaction now? Then for writing a reaction, out of this, I know the one which is present on the left hand side is acting as an anode, and the one which is written on the right hand side according to the rule is acting as a cathode. Since it is an anode, so it will undergo oxidation. Now oxidation, out of these two components, one will act as an anode and one will act as a cathode. Sorry, one will act as a reactant and the one will act as a product. Again the same thing from these two, one will act as a reactant and one will act as a product. So from this, now let's see what will happen on anode, which reaction. Simply suppose I am considering this zinc first as a reactant, then ultimately this zinc 2 plus will act as a product. Let's see the second possibility also. Second possibility, if I am writing this zinc 2 plus considering as a reactant, then this zinc will be a product. And I know that since being an anode, the oxidation will take place. That means there will be a loss of electron. And if there is a loss of electron, then after writing this, now just confirm that which reaction is correct one. Then I can say that zinc is losing zinc 2 electron and producing zinc 2 plus, means it's a correct reaction. Zinc 2 plus is giving zinc, and this is possible only after gaining an electron, not after losing electron. That means this reaction is wrong. So on anode, this reaction is taking place, means zinc is giving zinc 2 plus ion with the loss of electron. Similarly on cathode, which reaction is taking place on cathode, then I can say there is a Cu2 plus ion and there is a copper. So there is a gain of electrons. So Cu2, one will be a reactant and one will be a product. So Cu2 plus, it will gain electron and will produce Cu. Suppose if the Cu will act as a reactant, then after gaining an electron, it will form Cu2 minus, not Cu2 plus. So this is the correct reaction. Cu2 plus gains 2 electron, produces Cu. Then finally, once I got the reaction on anode and cathode, I will write cell reaction then. For cell reaction, the rule says that all the electrons should get cancelled. If the electron is not equal, then make them equal by multiplying by some suitable number. Then here I can write zinc plus copper 2 plus, which gives zinc 2 plus copper. So finally, by using from the cell representation part, I can say that I write this whole reaction also. Means the reaction can be written just by observing to the cell reaction. Now in exam, they generally give the cell representation and they ask to write the cell reaction. So in this way, we write the cell reaction. So let's see the another example for the same. PB, lead electrode. Another cell representation, we have to write its we have to write the reaction which is taking place in this particular reaction. So for reaction, let's see anode and cathode. What is anode here? This is anode, that is the left hand side part of the left salt bridge. So here I can say that Pb, the lead produces Pb2 plus 2 electron. That is oxidation, I can say. And then Ag plus 1 electron gives Ag. That is on cathode. This reaction is taking place on cathode. So this is reduction reaction. Now after adding both the reaction, finally we will get a cell reaction. So to get that cell reaction, the electron should get cancelled while the addition. So it's a 1 electron, there is a 2 electron. So multiply this by 2. So when it is multiplied, we will get 2 Ag plus 2 electron. Will give 2 Ag. Multiply by 2. And then add. Two electron get cancelled. From here we get we get 2 Pb plus 2 Ag plus, which gives Pb2 plus 2 Ag. Pb, it is in solid state, Ag plus ionic form, that is in aqueous state, again ionic form, that is in aqueous state, and this is Ag is a solid state. So this is the cell reaction, that is for this particular electrode. Then so ultimately from these two examples, I can say that generally we write like this is a reactant and this is product, this is a reactant and this is a product. Similarly, this is a reactant and this is going to be product, and this is the reactant and this is going to be product. But this happens, this is only in the case when there is a positive ion. Suppose if there is a negative ion, then the charge, then you have to take then the things is exactly opposite. Like this will become reactant and this will become product if there is a negative ions. Now let's see how to write the reaction for this particular this particular representation. That is zinc and H plus H2 and platinum. On the left hand side, there's zinc and zinc plus ion, but there is a H plus, there is a one gas also, and then platinum. Now is a way how to write like the representation of this particular solid H2 gas, where the gas is used, the first question. Then simply let's see the representation of this particular part, that is H plus and H2 and platinum. Suppose with this electrode, I'm talking about this second side electrode, that is on the right hand side. There is a solution which contains the electrolyte, that is H plus ion. So there is a H plus ion in a container. This is a platinum metal, I can say, sheet. This is a inert electrode. This is a metal of platinum. This is a platinum electrode which is inert in nature. H plus ion and platinum metal. Generally in this case I can say this is the electrode and zinc ion, and the reaction is taking place between the electrode and ion itself. Like here the Pb and Pb2 plus. The reaction takes place between the Pb and Pb2 plus ion. But in the case of this, the platinum which is acting as an electrode is inert in nature, and being inert in nature it will not take part in a reaction. Then H plus ion, where the which two components are there where the between which the reaction will takes place. The one component is H plus ion. So in this reaction here we are passing hydrogen gas. The hydrogen gas under 1 atmosphere pressure. So that hydrogen gas comes into the solution, and then it produces H plus ion, or H plus ion produces H2 gas. That is, a reaction takes place between the H plus ion and hydrogen gas. And here this reaction takes place on the surface of this platinum, that is on the surface of this electrode. So ultimately here I can say that the reaction takes place between the H plus ion and H2 gas. So if you are not writing, in this case, if you are not writing the hydrogen gas, the person will not be able to write the proper reaction. So the rule says that suppose in addition to the ion and the electrode, like ion and electrode, if there is some other component which are very important or which are taking part in a reaction, that other component should be written between the ion and between the electrode. And here the hydrogen gas is one of the very important compound, because if you will not consider the hydrogen gas, you will not be able to write the full reaction, because the reaction is taking place between these two only. So the rule says that if there is any gas or any salt which is taking part in the reaction, then it should be written between the ion and between the electrode. That's why the hydrogen is written here. So suppose if anyone is asking how to write this, then first half cell if I am writing, then half cell, first write ion. For half cell I am saying first write ion. Its a concentration is suppose 1 molar. Then you have to write the gas whose pressure is 1 atmosphere, and then finally your electrode. And the same thing is written here. Now let's see how to write its representation now. For representation, the reaction will take place on anode and cathode. So first anode. Anode, it is zinc and zinc 2 plus. So zinc will give zinc 2 plus ion plus 2 electron. The reaction is oxidation, I can say. The cathode. On cathode, H plus ion takes electron and produces H. But we know that hydrogen never exists in monoatomic form, it's always diatomic. So H2, 2 electrons will be gained by 2 H plus ion. This is reduction, I can say here. The platinum being inert in nature, it doesn't shows any interest in a reaction. There is no interaction of platinum inside the reaction. Just provides surface for the reaction and for the gain and loss of electron with the other electrode. Cell reaction. Electron will get cancelled. So we will have zinc plus 2H plus ion in aqueous state, which will give zinc ion in aqueous state plus hydrogen gas. So this is the reaction. Now let's see one more example based on the same type of thing. Nickel solid, nickel 2 plus ion, it is in aqueous state. The next is Cl minus in aqueous state, Cl2 which is a gas whose pressure is suppose 1 atmosphere. If you know the pressure of a gas, then you have to write it. And platinum which is in solid state. Again I can say this part is like, again like the same. I can say there is in a solution, there is a chlorine ion and we are passing a chlorine gas, and the platinum is an inert electrode. Now how to write the reaction? Anode, the reaction taking place on anode first. Anode, it is nickel. Nickel will give you nickel 2 plus. plus 2 electron. Oxidation. Cathode, where reduction takes place. Now there is a negative charge, and I said if there is a negative charge, generally we consider this reactant, this product, this reactant and this product, right? But if it is a negative charge, then as I said, you have to move in a reverse direction. That means this is a reactant and this will be a product. Because if the Cl minus is reactant, then it will gain electron because the cathode reduction will take place and reduction will gain of electron. And if it will gain electron, then it will carry more negative charge instead of losing a charge. And here I want to remove charge, then it is possible only, and here it is Cl2. So if Cl minus, you are considering Cl minus is a reactant, then charge will increase and you will not get Cl2. So here the reverse, that is a Cl2 will be there and it will gain 2 electron and will produce 2 Cl minus. So reduction reaction. Cell reaction will be two electrons will get cancelled and we will have Ni in a solid state plus chlorine, which is going to be in a gaseous state, will give Ni 2 plus 2 Cl minus. So this will be the reaction. Now the question may be like, they will give you the reaction and you have to write the its cell representation. The example I can say magnesium plus Pb2 plus ion, which gives Mg2 plus lead. Then how to write the cell representation? Then simply I will say just find out that which is undergoing oxidation, which is undergoing reduction. Then I will say this is 0, this is plus 2 and this is plus 2 and this is 0. Then this magnesium undergoes oxidation. There is an increase in electron oxidation and this undergoes reduction. So since this undergoes oxidation, that is an anode and this will act as a cathode. So while writing anode will be written first with the electrode. Magnesium is the electrode and Mg2 plus is an ion. So how it will be written? Mg in solid state, Mg2 plus in aqueous state, which is a cathode here, salt bridge, cathode is a lead. So Pb2 plus aqueous state and then Pb, which is in solid state. Either directly decide or you just divide whole reaction to two parts. The second method. This is the shortest method, I can say. In a second you will come to know. Or we can, the whole steps I can write like magnesium. Divide the reaction to two parts, magnesium part and lead. So second cathode, Pb2 plus gives Pb. From this I can say that there is a loss of electron because magnesium is getting converted into Mg2 plus, means there is a loss of electron, and Pb2 plus is getting converted into Pb, that is gain of electron. Loss of electron, that's why anode, oxidation. Gain of electron, that is a reduction, that's why it is a cathode. And after that you can write the reaction here. See, suppose during the reaction, for example, suppose if you have a question, aluminium, 2 moles of aluminium plus 3 moles of Fe2 plus gives 2 moles of aluminium 3 plus 3 moles of Fe. Now while writing a cell representation, again here I can say 0, this is plus 2, this is plus 3 and this is 0. If you want, you can write the reaction, split the reaction, 2 aluminum gives 2 Al3 plus 6 electron will be there because each aluminum is giving 6 electron and we have 2 aluminum. Similarly 3 Fe2 plus how many electron? Each Fe2 plus will give you, each Fe2 plus will take 2 electron, 3 Fe will take 6 electron and will give you 3 Fe. So this is undergoing reduction oxidation, so will act as an anode. Aluminium 3 plus aqueous and then Fe2 plus and Fe. Now in this case, while writing a cell representation, always keep in mind that the coefficients are not written in a cell representation. This coefficients comes into the picture only to equalize the number of electrons. So while writing a cell representation, the coefficients are not considered. So generally in exam they gave cell representation and they ask reaction, or they give reaction and they ask cell representation.